Hello, welcome. Okay. So, last week we made this window and it's purple. It looks a little bit different on the meeting, but it's purple and we can move it, we can close it. This week we're going to add the player and we're going to make it move and we're going to learn about delta time. So first things first, let's do a little bit of organization because right now it's pretty messy. So we have like all of our code in the main file right now. So let's go make a setup file. So setup.py, and then what you're gonna do is hopefully you guys have your IDEs open if you want to follow along. You guys need time to do that. Just say in the chat if you need to. Okay, I guess not then. So let's get started. In our setup, we can move a few things. So we can move all this straight into setup because we want to like everything that's kind of like just like a basic thing that you might need for every, because we're going to be importing our setup file into every single other file in our game. So like our player file, our game file, these are all going to be in their own files to keep things organized. So we want to keep this like just very, very important things. So we want to first of all import Pygame. We want to initialize Pygame. Then we want to set the screen width and the screen height to these values, right? So this is exactly the same thing. I'm just renaming the variables so that they make more sense in a wider context because we might have a player and we want to know like what is the width of the player. We don't want to confuse it with the width that we had here originally, so I'm just labeling this screen_width, and I'm putting them in all caps because this just denotes that it's a constant, so we're not going to be changing the screen width like when we're playing with it, right? And then we have the screen here. I'm going to make one more variable and I call it dimensions, and it's just going to be a pygame.vector2 of screen width and screen height. So pygame.vector2 is basically like two values, so kind of like a tuple, but so like if I have a tuple here like 1 or 2, like this is a tuple here, not in here, right? And what we want to do is we want to basically, this pygame.vector2 gives us some extra functionality, like finding the angle and finding the magnitude. This is like things that are like related to vectors, which you'll learn in calculus of vectors, but you don't need to worry about that for right now. We're just putting this in pygame.vector2 because it'll let us use it more effectively in with other vectors. Okay, so next thing, we can make it a little bit better by adding a caption to our game. So in the top, you'll see that we have like a little like a bar at the top, and it'll have like the name of the window. We can change this. So pygame.display.set_caption, and you can set this to any string you want. So we're just putting these two quotation marks to show us the string, and we're just going to write geometry dash because that's the name of our game. Now we need to get all the stuff that we put in here, and we need to somehow get it into our main file. So what we can do is from setup import star. So this import star will basically just like import a copy of all this. So that's why we don't have any variables in here that we need to change. So import star, and then this should work, and there you go, it still works. So make sure after you make like any small change that you check that it still works after, because if you add like 10 changes, then you're not going to know and something breaks, then you're not going to know which one of those 10 changes you made actually broke the program. So what we need to do now is we are going to just clean up a little bit. I'm going to make this boring and just do 0, 0, 0, right? And that will just make the screen entirely black. Alright, so now we need to add our player. So we have our screen here, and it's just a fully black screen. Let's add a player. So you're going to hit new, right click, new, Python file, player.py. And in our player class, we're going to set up import star. So we're going to import all of these variables from setup. And then we're going to make a class. So we're going to make a player class. So class, player, if I can spell that. And in this class, we're going to be like defining like a blueprint for what a player looks like. So if you like, so it's going to be like a collection of all kind of variables and methods, which are functions inside of a class. There's just going to be like a collection of variables and methods that are related to our player, and these variables will be independent for each player. So like if, for example, we had a player and we initialized it, so we have this special function called underscore underscore init underscore underscore, and if we initialize this player with something like self.position, and we set our position to be 0, 0, right? And let's say we had another player that, like, let's say we had player 1 is equal to player, right? And okay, we'll just put in the position here as an argument that you can pass in, right? And we just set the first player to be at 0, 0, right? And then let's say we want to also make the player be able to move, so we'll be able to update the player, right? And we'll just do self.position, and we're going to just set it to I don't know, 1, 0, right? So this is just like an example for right now, but let's say we had this, but we also want to have another player, player 2, right? It's just easier to have a class here to keep track of all these different things, so that in case we want to put this player at 2, 0, we don't need to write, like, I'll show you what like the other way without classes, right? So we'd have player 1 underscore position is equal to the position 0, 0, right? And let's say we wanted to move this player, so player 1 position, and we're gonna equal that to 1, 0, right? And then if I want to have player 2, I need to have player 2 position is equal to this, right? And 2, 0, and so on and so forth. But like if I wanted to have like 3 players or 4 players, then this is going to be a lot of work, especially when you get a lot more variables. So what this is going to do is just allow us to make a blueprint for a player and give us the special, like, unique, or not unique, but like variables for each separate player, right? So let's declare some variables. The first thing we need to know about our player is how big it should be when you're drawing it. So width and height, and we're going to set it to 50, 50. So this is 50 pixels by 50 pixels. So what we did here was assign 2 variables on the same line. It looks pretty fancy, but it's essentially just width equals 50 and height equals 50. Like, these two are equivalent, right? But this one just looks a little bit cleaner, and you just use a comma to separate out these values. And then the next thing we need to know, gravity. So the player is going to be affected by gravity, and we're going to use a vector 2 to show that we are going to not be affecting the x direction in our game, right? So where is paint? Here it is. So if our player is like this, right? If you remember from physics class, that gravity is going straight down, right? So it's not affecting like this side or this side. It's only going straight down. So that's why we have our vector here. Our components of this vector is 0 on the x, and we're having this 1900 on the y. And the reason that we want to have a positive number, right? So we're saying let down down be positive. It's just because the way that Pygame kind of makes the window is this way is positive, this way is also positive. So that way this like bottom right corner will be the screen width, screen height, that coordinate, and this coordinate is 0, 0. Okay? So that's why we need a positive direction to go down. Alright, so we have our gravity, we have our width and height. Let's make one more variable. We're going to call this the color, and we'll set the color of the player to be bright red. Okay, now when we initialize our player, each unique player is going to have its own position, it's going to have its own velocity, and have its own acceleration. So we're going to have our position, and we're just going to set the position automatically, because the player in Geometry Dash, it's kind of like on the left third of the screen and like kind of near the bottom. So we're just going to set that automatically for ourselves. Later, we're just going to put in the center of the screen right now. So screen underscore width divided by 2, screen underscore height divided by 2. Okay, so let me explain that. Here is our thing. Let me erase all of this now. Great. Okay. So if our screen is like all the way here and all the way down, the middle of this line goes here, the middle of this line goes here, and where they meet, this is the center of the screen. So our player is just going to be like this, because we're going to be drawing the player from its left hand, because when you draw things in Pygame, we're going to be drawing it from the top left corner here. So if you can imagine that the player will be like this. Okay, great. So we have our position. Let's make a velocity. So self.velocity is going to be equal to Pygame.vector2, and we'll just set this to a value like 10, 0. So our player is going to be moving this, oops, that is not the right tool, is going to be moving in this direction because we set a positive velocity. So positive velocity, 10 pixels per, we don't know the time yet, we'll be deciding that later. Right? So this is our velocity. And then finally, acceleration. So it's just going to be Pygame.vector2. And we know that the acceleration is just 0, 0 for now. We will add gravity later. That's going to come in later because I just want to show you guys like the player moving for right now. So when we update our player, we want to update a few things, right? So if you remember from physics class, your kinematic formulas, we can actually use those to determine like the position and the velocity. So our velocity is just the acceleration, right, multiplied by whatever time that has passed, right? So we'll just have in a time. So what we'll do is just do time, right, and multiply it by the time. So the velocity is the change in acceleration multiplied by the time. Let me write that out. So we have velocity is equal to change in time. So change in acceleration times time. Your acceleration is in meters per second square, or in this case pixels, and the time is in seconds. So when you multiply this becomes s, this cancels out, and you get pixels per second, which is the units for our velocity. The next thing is the position, so we'll just use d, change in position, is equal to your velocity times time. Alright, so this is a pretty good approximation of physics. Of course, we haven't dealt with friction here, we haven't dealt with air resistance or any of that stuff. We don't need to worry about that. It's just Geometry Dash, so it should be okay. So here we have pixels per second times the seconds. These cancel out, and you get the pixels that you have traveled. Okay, so these are the units for direction. Alright, so next thing, self dot position equals self dot velocity times time. Alright, now we need to draw our player. So in computer rendering, we need to first have our player. We need to update it to tell it where to go, right? Like in the computer's brain, like telling it, okay, yeah, you need to move the player like 10 pixels to the right. And then finally, we need to draw that onto the screen. So those are our 3 steps that we need to do: initialize, update, draw. And then we're gonna have to keep updating, update, draw, update, draw, update, draw every single time, every single frame, right? Okay, so draw function, and we're gonna take in a parameter. So there's a parameter here called the screen, and what we need to do is use pygame.draw.rect, and we're gonna draw a rectangle onto the screen. It's gonna be the color self.color. So color is 2225500, which is red, right? RGB. And then once we have the color, we need to tell the Pygame where to draw our rectangle. So we need to define 4 things. First one, the top left corner, sorry, that is at self.position.x. So you might have noticed we use pygame.vector2 to declare the position. And one thing we can do is we can get this value or get this value just by writing .x. Of course, it's the same thing with a tuple. Like if you had a tuple like 1, 2, right? If you say this is like a equals this, if we print out like a0, that would give us this 1, and a1, sorry, would give us this 2, because it's -1. So index starts at 0. In Pygame, in vector2, you can just use .x and .y, so .position.y. It just makes a little bit more sense. It looks a lot cleaner as well. And then finally, we need to know the width and the height. So width, self.width and self.height, right, which we declared at the top, which is 50 by 50. And the reason that we're using width and height at the top here is because these variables will be the same for every single player. And the reason we want to put in a variable is in case we need to use the width in other calculations, like for example, for checking whether we're going to hit a wall, we're going to need to use the width for that. And it's just easier to have it all in one place, where if you need to change it, then it'll change for every single value in here. I'm sure you guys know. Okay, so this is our basic player. Let's actually get this guy into the game. So go to your main file, and we're going to from player, import player. So what we've done is we're looking into a player.py file, and we're going to import this class player. Okay, great. And then what we need to do next is we need to make an actual player. So we'll just call it Andrew. Just call it player as well, or just P, just to remove any confusion. And we're going to do type out player with a capital P, because that is the name of the class. And then you need to put these parentheses here to show that it's an instance of this class. So this is the blueprint for a player. And if we want to make like a copy, like when I actually build this player, we put in these parentheses, and it'll show that it's a different player than if I have P2 player. This is different than this player, if you guys understand that. Okay, great. So we have our player. Now we need to actually draw our player and update our player. So let's go here, p.update. And we need to give it a time. We'll just say, like, I don't know, we'll say 1/10 of a second has passed. And then we're going to say, we're going to, after we draw the screen, then we're going to player.draw, and we're going to draw onto the screen. Okay, let's see what happens. As you'll notice, here is our player. He is not in the position. So let's like up this up a little bit more. And he is moving very, very slowly. Let's make him move 100 pixels a second. And this is the wrong file. He needs to run the main file. And he is not moving. Okay, why is that happening? p equals player, player.update, player.draw. Okay, how about we put in a delay. So right now my computer is running this as fast as possible. So what we can do is just introduce a little bit of delay. So pygame.time.delay. So if you have ever played a computer game, you're probably familiar with the term FPS, which stands for frames per second. So you'll get a frame, like usually games are about 60 FPS, so 60 frames per second. And what we can do here is if we want to have 60 FPS, right, then what we can do is say, okay, so we have 60 frames per second for 1 second, right? This is frames, right? So this is the math. If I want to get 1 frame, want to like find how many seconds is 1 frame. So we just divide both of these by 1/60, right? This is the same fraction here, right? This will cancel out to 1, so we're not changing anything. This becomes 1 frame every 1/60th of a second. And if we are to calculate that, so you do 1 divided by 60, you get this. So 0.016. Okay. And I believe that this should be in milliseconds. So we need to multiply by 1000. So you just move it up 3 decimal places, that becomes 16. Alright, let's try that. And it's still not moving. Why? Self.position .x, self.position.y. Maybe did I like make a typo? Okay, let's like see how our player is updating. So this is useful for debugging. Okay, so we can see here that as we're debugging, the player is updating. Our velocity is updating, right? But our position is not changing. So from what I can see here, one of these values must be 0, and I can see the acceleration is 0, which is changing the velocity. Here it is. We need to add the previous times acceleration and velocity, and now our player is just zoomed off into the distance before we can even see what's going on. Okay, so now our player is moving. So how did we get to this point? Alright, so in our update function, we have our velocity, and we're adding like the change in acceleration. And for our position, we're adding the change in velocity. So adding it. So make sure you guys don't forget that like I did. Okay, now I changed a bunch of other stuff. So I set the velocity back to 10 pixels per second. And here I put in, we're delaying for 16 seconds, right? Or sorry, 16 milliseconds, right? So 1000 milliseconds is equal to 1 second. So ms is just short for millisecond. Alright, and then here, since we know our speed is in pixels per second, we're going to put in 16 divided by 1000, so you move the decimal place 3 places over, and you get 0.016 seconds. In this way, we get our player moving. Let's make him move a little bit faster, so I'll put this in as like 50. Okay, great. He moves a lot better now. So this is kind of like how a beginner would write like code like this, but not all computers are built the same. Some of us have potatoes, and some of us have stolen computers from NASA. So what we need to do is be able to make a system so that anyone who runs the program will still get the same result. So for example, let's say your computer was like really slow, and I'm going to simulate that by doing a ton of calculations in our update function. So every time we update the player, I'm going to do like a massive calculation, and it's going to slow down our game, and you're going to see that the player is going to not be moving correctly. It's going to be moving a lot slower than if it was just running normally. So let's look at it normally. Okay, he's moving pretty smoothly. He's going like this, taking quite a bit of time to get to the end. Now let's put in a massive calculation. So for I in range, what's that? 1, 2, 3, 1, 2, 3. So 6 zeros. That's 1 million. So we're iterating through a million values, and we're just gonna add 1 to this value here. And what this is gonna do is gonna slow down. This is going to lag the game to show why using a set time doesn't work. So if you run it now, this guy's moving a lot slower now. Let's even bump this number up to show you. So that's 10 million now. He's barely even inching forward. And just to show you like the difference, I'm going to comment this out, so it's not going to be running. And now, oh, that's moving a lot faster. We can even bump up this speed, and I think it will be a little bit more clear. So here's moving very fast. Put this in. Now it's moving super slow. So if you were having like a competitive game, like if this was like Valorant or whatever people play these days, this is going to be pretty bad if someone's moving a lot slower or moving a lot faster than other people. So what we need to do is find a way to calculate how much time people missed in order to more accurately reflect how it's actually supposed to be, so it's the same for everyone. What we can do is something called delta time. So delta time is the time in between each frame. So let me like clear this. I don't think there's a button to clear it all, but I can just do this. Great. Okay, so let me explain. If we have a frame, let's say this is a frame, right? I generated a frame using our draw function here, right? And then let's say we do all our updates and stuff here, and then this is the time in between each frame. So we call this delta. So this is the Greek symbol for delta, which means change in time. So change in time. That's what this symbol means. You've probably seen it before in math or physics class. So we're looking for the change in time between each frame. And not each frame is made the same, right? Some frames are going to be like take a long time to calculate. Some frames are going to be like really quick to calculate. This is also delta time, right? So we can calculate this value, how much time has passed in between each frame, and then we can use that in the calculation for the next frame, how much time we missed, and this will give us like a pretty good approximation of how our player is moving, and I'll show you guys the example. So after we make our player, we need to make delta time, and we're going to set this to 0. So I'm just typing out the word because I don't know how to make a triangle in the text editor. And then we need another variable, and it's called last delta time is equal, or last time, sorry, is equal to pygame.time by get underscore ticks. So get ticks is just going to give us how many milliseconds have passed after we called pygame.init. So at the very beginning, it's going to be 0, and it's just going to keep counting how much time has passed. So while we are running, we want to say the current time is equal to pygame.time by get underscore ticks, right? And then the delta time is equal to the current time minus the last time, right? So we need to put in one more line and this will make sense. So last underscore time is equal to the current time now. So if we have a frame, right, the previous frame will have the previous current time, right, and this becomes the last time. And we go through all of this, and we come back to the top, and we get the current time again, right? All of these things are going to take a lot of time to do. Like, computers are fast, but it still takes quite a bit of time to like do some calculations of like collisions and doing calculations of effects and stuff. So this is going to take a couple milliseconds, and when we come back here, we're going to have a new current time, which is several milliseconds ahead, and we're going to find the change in time, so the current time minus the last time. So it's a little tough to wrap your head around it, but like you have to remember that this is a loop, so this is constantly going over and over and over again, and these variables are just like storing the previous time and the current time. Alright, so we need to do one more thing, which is, since this is given in seconds, so this is given in seconds, you can even check if you control click on like any function, it'll get the time in milliseconds, right? And we want to divide that by 1000 to give us the time in seconds. Gives us time in seconds. Great. So we have the time, we have this time. Now when we calculate it, we can just give in delta time, right? As we update, this is how much time has passed. And then we don't even need this anymore, because our program will be able to like calculate how far it should be. So if like only a little bit of time passed, then it's not going to move a lot. But if a lot of time passed, then it's going to move a lot. Okay? And then we can go back to our player, and I'm just going to change this time to delta just to make it a little bit more consistent, but of course you don't need to do that. And our thing right now is not on, so we're just going to show what it normally looks like. So player is moving, perfect. Now I'll let you guys look at that again. It's moving normally. I'm going to put in this lag thing to make like simulate a lot of calculations. I'm going to just do that so it's not lagging me too much. As you can see, the player is like moving like rubber banding a little bit, not really, but like he's like jittering around, but it's still going at the same speed, right? It's not going super slow, and this is just how we can do it, like even when we do have lag. So we don't need this anymore. That is our player. That is delta time, and we have our player now. So that's mostly what I had planned for this meeting. I can just explain one more thing. When we're rendering, whatever is rendered first is going to be at the bottom, and everything rendered after it will be on top of it. So I have screen.fill here, and then I have player.draw. If you do this, you'll see the players on top of the screen. But a lot of people make a mistake sometimes, and they like draw the player first and then the screen, and then you can't see the player at all because the screen is just like filling on top of the player. So you need to make sure the order that you draw things in is correct, so that you don't get a bunch of like incorrectly drawn things. Okay. So there's one more thing we can do. It's a little fancy, I guess you could say. We can make an icon like this thing. You see that little snake there? That's the Pygame snake. We can change this icon to be whatever we want. To do this, we can just kind of like look at surfaces, and we can put it onto there. So I'm going to explain to you guys what a surface is. So I'm going to say our icon is going to be a Pygame.surface, and our surface is going to be like it's kind of just, oops, you need to actually put something in here. So 32 by 32. Our surface is going to be just like kind of like a screen, but like we're going to be putting inside of it. We're going to say that this surface is going to be 32 by 32 pixels wide and width and height, and we can draw onto the surface. So icon.fill, and we can put in white, or in this case I should probably put black because that's I'm using the dark mode theme. And then what we need to do, we need to put in parentheses, right? And this is RGB values because you're using .fill. And then we need to actually write something into our thing. So I'll show you guys how to make text in Pygame. So I'm going to set the font to use is pygame.font.sysfont. So this will use your computer's system font. I'm pretty sure every computer now will have Arial. You can download fonts and put them in. You don't have to use a system font, but we're just going to use this for now because we don't need to actually import any actual files. And what we can do is we can set the text is going to be equal to font. So this is a font object, and then we're going to render something using the font object. So this is actually like a class. It's actually a file, but we have render. Here it is, render. We can render some text, and it will give us a surface which we can put onto our other surface, and then we can set this surface as our icon. So it's a little bit confusing, but hopefully you guys will understand once I actually write it out. So we're just going to use the initials for geometry-gd. So we're going to render that text. We're going to want it to be anti-alias. You don't need to worry about that. Just leave it as true, and you won't go wrong. And then finally, we want the color to be black, or in this case, we want the color to be white to have contrast with our black background. Okay, next thing, we need to actually paste this text onto our surface. So right now our surface is just completely blank. It's filled with white. Now we rendered a font object with the text GD. So it's gonna have GD onto it, and then we're going to put onto the surface our text. So icon.blit, and blit will just let us put another surface onto another surface. So icon.blit, and we want to do Pygame, or sorry, no, we'll just put the text, and we're going to put in at the position 0, 0, right? And then we want to do pygame.display.set_icon, and we're going to put on the icon. Now this should give us an icon right here, and it's kind of off center, so let's fix that. We can set the text to be like, we can like shrink it so that it fits inside of it. So pygame. So we're gonna set the text is equal to pygame.transform. So Pygame lets us transform surfaces. So in this case, our text. Okay, no, I don't need to sneeze. Okay, pygame.transform.scale. I want to scale the text object. I want to scale it to 28, 28. So our surface is 32 by 32. We're making this 28 by 28. And what we're going to do is we're going to end up pasting it at 2, 2. So this way, it will be like centered, and there will be a little bit of room on the outside, so it's not too cramped in there. As you can see, it's now perfectly in the center there. Alright, so that's about it for the meeting. Hopefully you guys enjoyed it and maybe learned something new. We're going to be probably making the game class, probably making some spikes and tiles next time. So yeah, stick around for that. Thank you for coming. If you have any questions, you can ask them to me right now. Yes, we will. I'll be posting the meeting recordings. It's just recording my voice, so you don't need to worry about your voice being in the video. Yeah. Any other questions? No? Okay, great.